Welcome to episode 4 of Look Up Tonight with the Orange County Astronomers. This month, we're showing highlights from our August meeting at Chapman University. OCA member Chris Butler gives us a great What's Up presentation focusing on the astronomical goodies awaiting us all in August and September. Scott Kardell, who is the Public Affairs Coordinator of the Palomar Observatory, will be sharing with us details of the current research being conducted using their many telescopes, including, of course, the world-famous 200-inch Hale telescope. As many of you will know, Mars is getting closer to the Earth than it has done in the past 60,000 years. But what does that really mean? What difference will that really make to the way we will see and experience Mars? Let's face it, the way the majority of the media has been handling the news about Mars, it's not surprising there are misunderstandings about exactly how big Mars is going to be in our sky. At public outreach events, many of us in the club have encountered these misconceptions to the extent that some people are expecting Mars to be bigger than the Moon. And I don't blame them. OCA member Chris Butler does a fantastic job of explaining to us all why Mars is getting closer to us and exactly what Mars will look like through a telescope. We hope you will come away from the program with a realistic expectation of what you will see of Mars when you look through a telescope, and this will allow you to appreciate the close approach of Mars much more.
Our beautiful, pristine skies of Orange County. It does help that it washes out everything else if you want to find Mars. This simulated view, yeah, it's pretty close to that. You just look out there and there's that, hey, what's that one thing, man? It's not a plane. If it is, it's just sitting there. Yeah, Mars is really an obvious naked eye object, which means everybody's going to notice this thing, okay? Lots of people, all through the giant community in which we live, not just the weird people who are here. Now, the problem I have with this situation is a little bit, this may be the view of the unaided eye, but the unaided media suggests it should look more like this. And this may be creating some impressions in people's minds which are not exactly right. They really think this thing's going to come in and scrape dirt off Mount Baldy. I'm not kidding. And it's really weird. People ask about it. What does it mean for us? I don't know. It's just a little dot. Come on, relax. It's fine. What's the horse sense of what's really going on here? Obviously, when we pass Mars on the inside track at what we call opposition because it's opposite the sun, of course we get a better look at it. We're closer. And when it's at superior conjunction, superior or beyond the sun, obviously, you see the little tiny Mars there. Hey, that's what we put up with a lot of the time for Mars. It's a small world after all, okay? It is half the size of the Earth. It's all the way back there. Mars varies in size a tremendous amount, almost more than any of the other planets. So when we do pass close to it, as we are this year, it is wonderful to get a look at it. We've done it back, I remember, in 1988 when I was a new member of the club, the year I did my first What's Up. And in 1956 was another one of our good close passes by Mars. As you can see, the size of Mars during those times was similar, okay? Very similar. Now, if you're an experienced astronomer and you know these things, you know that how close we pass Mars follows in a regular cycle. Of course, the planets all go around in this direction. We do this once a year. Mars does this every 687 days. The place we catch up to it varies from year to year to year. And let's say like 1993, it was a so-so pass. Then 1995, Mars was definitely farther away. 97 was about as worse as it could be. And notice Mars is about twice as far away and only half as big in your telescope. Half as big. That's really hard to see details. Then in 99, Mars a little closer. 2001, not too darn bad. And then this time in yellow there, a really good pass. There are other years of famous passes there. 1939, when War of the Worlds went on, right? That was the Martian pass, which I believe was in October. I'm not absolutely sure on that. 1971 was another well-known pass. 1956 is an especially well-known one and was very good. Where's the theoretical best place we could ever catch it? When Mars is closest to the sun. Now that point in Mars's orbit is right here. It's actually even a little bit closer than that to Mars than I drew here. So this is just a year where we happen to pass it about as theoretically good as we can, and it's not that big a deal, except to say that next year, or next cycle, about 2.5 years from now when we pass it, it'll be over in here, and it won't be as good. It'll be a number of years till we come back around and catch it, I believe about 15 or so, until we get another really, really good look at it. The way Mars is tilted towards us, the South Pole is pointed slightly towards us. Purists, old-timers in the room, you believe that south should always be shown at the top in an astronomical diagram, don't you? I will never do that. It makes me feel like I have to puke, okay? I learn the planets with north at the top, as God intended, right? New Zealanders are ready to throw things, I know. And then I look in a telescope and I say, how weird, the planet's upside down, which I think is okay. So this is with north at the top. In a telescope, normally, the top pole will be pointed towards you. Now, interesting thing, you may wonder when we pass it each time close, do we see Mars tilted differently? No. When we do a good catch on Mars, especially as close to the theoretical best as you can, every single time Mars will be tilted this way with respect to you. Why? Because a planet's axis is fixed in space as it goes around. Therefore, we catch Mars when it's closest to the sun during a particular point in its seasons. The southern spring is underway as the South Pole tilts towards Mars. It always does it in that part of the orbit. So otherwise, Mars' seasons would be slipping around, okay? We would have summer in January if the Earth was doing that, okay? And so because of the Martian seasons, every time we get to see that. Now, of course, Mars does rotate in 24 hours, so you do see different features of Mars as the ball rotates as you watch it for several hours. Night to night, however, if you're watching Mars, because Mars' day is slightly longer than ours, if you always look at exactly 9 o'clock at night, you go back and look at Mars, it looks like the planet's backing up if it's rotating to the west slightly. Why? Because you waited 24 hours, not the Martian day of 24 hours, 37 minutes. It has to catch up slightly to be back where you left it the night before. As far as learning weird and exciting names and features, there are all kinds of them. Up in the upper left here, that globe of Mars, these are all rotated 90 degrees from each other. In the middle of the diagram, we have Sinus Meridiani, and I love that name. It actually refers to the meridian of Mars, the 0 line of longitude. When we discover a new planet, we have to figure out where it goes. On Earth, every major astronomical community decided Earth's 0 longitude would pass through their capital city, by the way. Seriously. The meridian of Paris, the meridian of Greenwich, Greenwich 1. Why? The British Navy, folks. That's what gave us the 0 line on Earth. On Mars, there's no one to fight, okay? So they just picked an obvious-looking feature, this thing in here, that actually is a long-looking thing, almost like a head of a snake out on the end of this thing. It has a distinctive twin-lobed appearance. That's the 0 line east-west on Mars. Now, if you jump over to this one, you have some very famous features. See this stuff over here? It's this stuff over here. So we've rotated the globe this way, brought this stuff into view. All the famous stuff, don't expect to see it. The canyon, the volcanoes, they just aren't obvious. That's one of the reasons space probes found them. Now, Tharsis is the area where the 3 great volcanoes joined by Olympus Mons up in here reside. And as you can see, it's not so contrasty, light and dark. It's just a lot of up and down, okay? But that's a local thing if you're a Martian. Sometimes you can see cloud patterns that'll appear on the edges of the volcanoes. Same for the Great Canyon that stretches through here. It goes through some light and dark patches that you might be able to notice. One in particular thing I want to mention is the Great Shark Fin. This you will see. Syrtis Major is the first thing you will see on Mars if it's rotated your direction. Obvious, big, dark, highland region of Mars. And right below it, the next thing you'll probably notice is this giant circular light area, which is called Hellas. Hellas Planitia is a giant asteroid strike, a super crater that's been filled in largely with sand dunes and thus is very bright. So you can look at maps like these and kind of look and see what you see on Mars. Speaking of what you do see on Mars, let's get honest here. Do we have any first-timers, college students, indentured servants? Anybody was forced to be here? Okay, if we have some first-timers, let's get real about what you're going to see, because this is what Hubble tells you is there. All right? Doesn't it really kill you in some ways. We've sent space probes to all these planets and gotten resolution, down like the size of a gnat on these planets. Kind of makes your telescope, your instrument, man, feel less powerful, And however, there are still lots of things to be done. Let's at least be honest. If you buy little Johnny or Susie that Kmart 3000B telescope, okay, what Mars is going to look like is this, okay? In all telescopes, Mars will not loom huge. It will be fairly small. So in Johnny's telescope, it is faint because it gathers less light. It is blurry because it has less resolution, and it's small. The child will cry. And you know why? The reason Johnny will cry? Because he's seen the pictures from Hubble, okay? So a little conditioning is important before we go to this. Now, for somebody who's an adult, maybe you just, like, somebody in our club keeps winning telescopes at RTMC. Somebody. So you win a telescope. It's an 8-inch telescope, a nice one. And you go out there, you're going to see a bright planet, you're going to see a sharp planet. What are you going to see first time looking? That. It'll be a bright orange dot, and it will look like it has nothing on it, okay? That's what I saw the first time I looked at it. However, what happens is astronomy is push-ups for your eyes, okay? For seeing contrast, details, and noticing things. It's good for you, folks. And if you look in there, you see, I think I see something darker in the middle. And then you start asking questions of the person whose scope you're looking through, like, is there a bright spot at the bottom? Like you're not sure, like they're going to laugh at you. And then gradually, you will start to see more and more. Want to check yourself? Draw a picture of what it looks like to you through the eyepiece before looking at a Mars map and see if you caught anything. I did that back in 1982, and I was amazed that I really saw stuff. Now, if you have a little more money, you might pull off something like this, all right? You might. So you've got your 42-inch Takahashi refractor. And you live inside it too. I love something. This is the poor man's great joy in the world. When there's a star party and somebody brings out this serious artillery, brings out Big Bertha, and the atmosphere has other ideas, and what they're getting is this. That's just great. Yeah, you got a big scope there, don't you, Buster, huh? Bet you wish that thing was on the moon. Now, seriously though, even if you're borrowing somebody else's telescope or something, there are other Marses. This is how I grew up with Mars. My interpretations of Mars, drawing it through the eyepiece. Something people have been doing for hundreds of years, recording how Mars seems to you, a highly personal way of looking at Mars. I recommend that you do this because in years later, an astrophotograph can be just an astrophotograph, but these things often, when you write notes on it, I think I see this, this looks like something, the weather conditions of this. I have fire ants crawling up my leg, but I'm not leaving the eyepiece. These things will mean something to you later. And of course, there'll be some artistic types that have their own take on it, All right, whatever. Now, of course, we all understand the big deal with Mars is not that it is a little orange dot or whatever this is that you see in your telescope. The point is, of course, we're talking about another world. Some guy did this, I don't know who. And this is really an exciting thing, obviously. We're not talking about a place where there's, gray rocks and black sky. No, this is a place with sand dunes, where the sun comes up every 24 hours, where there's frost in the morning, where there are clouds, where there is wind. This, if not really the Earth, I like it better than Phoenix, okay? Especially in the summer. So this indeed is a world, and one of the exciting things, we do live in a time now where we may be remembering now how we saw it before people had been there, and our kids may live in a world where they can't imagine looking at Mars without knowing that people have been there, kind of like the moon is now. I would like to think that we are on the cusp now of doing something like this in my lifetime. I'd like to have that happen. Now, what will inspire us? What will we discover on Mars that finally breaks the logjam and we decide that this is worth the money? I don't know. I mean, almost anything's possible. You never know. I just have the feeling that if something does inspire us, we will find a way to do this.
The Palomar Observatory is one of the most famous observatories in the world and is the home to the 200-inch Hale telescope. This huge telescope has been in productive use since 1948, although it and the site has undergone extensive technical improvements over the years. Scott Kardell, who is the new Public Affairs Coordinator for the Palomar Observatory, gives us a presentation covering the many research activities taking place on the mountain today.
Many people never get a chance to see a lot of the other scopes on the mountain. And the 18-inch Schmidt is actually the oldest telescope up there. It started operation in 1936. And it's not used anymore, which is unfortunate. It's a really cool telescope, and a lot of neat stuff has been done there. So we also have another Schmidt telescope on the mountain. It's the 48-inch, now called the Ocean Telescope. Some really cool things have been done there, of course, over the years. Most famous, well, first of all, another Russell Porter drawing. That's how the telescope used to operate, by the way. So we had a night assistant here at the control board, and the astronomer guiding while they were taking a picture. They would have a glass plate that would actually be, so the light would come in through the front, hit the main mirror, bounce to another mirror, which sent it over to here, where they'd load a glass plate and take their exposure. And during that time, the astronomer would guide on a star to make sure that they were doing okay. Things have changed a bit now. But while a lot of that was done, probably the most famous thing there was Palomar Sky Survey. Back in the 50s and again in the 80s and 90s, they photographed the entire sky visible from Palomar. But they've done other things there than just the sky surveys. One of the things lately is that they've been looking at gamma ray bursts. The 48-inch telescope is now an automated telescope, and once it gets in that pipeline of being automated, what happens when someone finds that this gamma ray burst has occurred, very quickly you can direct this telescope to where you want it, where you think it is. Now, if you look and you see the big circle there, the circle is the area where a NASA satellite says, we think there's a gamma ray burst somewhere in there. Go take a picture. And so the photo on the right is from the sky survey, and there's nothing there. The one on the left was one taken from the 48-inch, and there's the gamma ray burst. It's been really important to hop on these gamma ray bursts really fast because nobody had any clue what they were at all, and they didn't last long. So you wanted to be able to get there real quick so that you had a chance to see it before it disappeared, and then have a chance to comprehend what they are. Also, the NEAT project has been on this telescope for a couple of years, the Near-Earth Asteroid Tracker. And I apologize, this image is kind of hard on your eyes, but you can see an asteroid moving there. And while the camera was only on the telescope for about 2 years, they found 189 Earth crossers, 20 comets. In the 55 years that Palomar has been an observatory, we're up to almost 6,000 total asteroids discovered there. That's how the telescope looks now. Kind of different from the Russell Porter drawing. We don't use glass plates anymore. It's kind of changed a lot. They've put insulation on the outside of the telescope now. There's nobody there controlling the telescope. In fact, the telescope's controlled right now from Yale University. You know, some people argue the romance of astronomy is gone because you don't have to be in the dome or on the mountain or in the state or even on the coast. I mean, you know, all the way out to Yale. But they're doing some really cool things. In fact, the telescope's recently gone through an upgrade. You'll see the picture in the top left. They had to remove the corrector plate because they're putting in a new camera. One, they wanted to remove the corrector plate because the camera was coming in through the front. And that's the camera coming in through the front in the lower right. And this camera has 112 CCDs in it. It drinks liquid nitrogen like you wouldn't believe, okay? Because those things are kept cold. It's 161 megapixels. And so the video we used to show at the observatory showed somebody holding a CCD that was 500,000 pixels and said it cost $1 million. Times have changed. This is an expensive camera, but you can certainly buy more pixels than that at Target than we were using when they were new. So what they're going to be doing with this camera is new survey stuff. Start looking at the sky again, but looking for asteroids, looking for quasars, looking for variable stars, looking for supernovae. Anything that changes, that's the stuff they're looking for. Okay, we've got other telescopes too. There's the 60-inch. The 60-inch is another telescope that will soon be automated. In fact, before this month is over, it'll be in service as an automated telescope. And probably the most famous thing that was discovered at the 60-inch was the very first time anybody ever saw a brown dwarf. You see the blob next to the big star on the left. That's the very first brown dwarf star that anybody ever saw. If you're not familiar with what a brown dwarf is something that is literally between a big planet like Jupiter and not quite big enough to be a star, sort of in that in-between case. Something that had been predicted for a very long time, and when people finally saw it, were actually extremely excited. Very cool. And Hubble photo on the right. Okay, if you've been up to Palomar, you've probably seen our big sheds. But most people think, oh, I wonder what you keep in that shed over there. Well, it's an interferometer. And it's pretty cool. Here's a view from the catwalk of the 200-inch. And you can see 2 of the 3 sheds and the central building. And what they're doing there, of course, is there is I think it's about a 16-inch telescope in each one of those. You see what looks like a silver pipe there. That's where they combine the light down to the central shack. And you don't get great pictures, but you get the sharpness, the resolution, as if the telescope was as big as the distance between the 2 telescopes, between those sheds. So right now I think they're working on average with something like 100 times better resolution than the Hubble. So we have a telescope here and one there, and there's a third one over here that kind of isn't in the picture. And the lights combine here in the central building. It's really precise work. So much so that when, if the 2 telescopes are operating and the star's over there, the starlight hits the one telescope slightly before the other, and so they have to adjust their positions so that the light comes to the central building exactly at the same time and in phase. Yeah. But with that, what can you do? Well, they've done things like Altair, which was mentioned earlier when Chris was talking about the summer triangle. They figured out that it's fat because it spins fast, and that's its approximate shape. It rotates, I think, in 11 hours, whereas the sun takes about a month. So kind of significantly faster. And what they do is they literally take sort of different slices as the star changes its orientation in the sky and can physically measure the diameter of stars, which previously, without interferometry, was only possible on things like Betelgeuse. Our smallest telescope on the mountain is being used to look for planets. Okay, that sounds backwards, right? You think we're going to do planet searches, we're going to use a 200-inch. No, we got a telescope with an aperture that's about that big. Kind of crazy. But what's going on is the astronomer, Dave Charbonneau, has got this wide view, and he's going to take lots and 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 lots of pictures of star fields, and is hoping to catch a planet going in front of one of them to produce an eclipse. This is used, of course, every clear night, the 200-inch. And here's an example of some of what they've looked at this summer. Not much. Asteroids, satellites of asteroids, comets, mostly far comets, because people are actually resolving nuclei of comets when they're far from the sun. They don't want to see them when there's all that dust around them. But also people are looking to see how the dust streams come out. I was there a few weeks ago when they looked at Mars with the 200-inch. We'll come back to Chris's talk with that one. There's a telescope that costs more than your house. And it looked pretty nice. Just about everything you can think of in astronomy, and that's just this summer. So I've been keeping track of who's coming and what they look at each night, and actually post a little sign in the viewing gallery when people come and see the telescope. Okay, the other thing that's going on now that I think is tremendously exciting is the use of adaptive optics. Now, no one ever thinks of the Hale 200-inch telescope and adaptive optics. You think of new telescopes with thin mirrors and computers and these little actuators under there that are moving the mirrors and stuff. You don't do that with a 14.5-ton mirror real well. Okay, it just doesn't happen. So what they do is once the light goes through the system of the telescope, then they do the adaptive optics. And so it comes out of the telescope here, goes into some mirrors just to get things collimated again, and then this is a deformable mirror. It changes its shape 1,500 times a second. They sense what the atmosphere is doing and correct for that with the deformable mirror. We have the fastest adaptive optics system in the world on the Hale 200-inch telescope. So, okay, that's without adaptive optics. That's with. So without, with. Now you see, we had previously just a big blob there. That's a double star, of course. Down here, that's a star, that's a star. Some of this other stuff is imaging artifacts that come in from the adaptive optics system. So on the left, top left, is the blob with adaptive optics turned off, and on the right, multiple stars. And graphically shown at the bottom, too. It's pretty impressive. This is pretty cool. We're looking at Pluto and its moon, and we're able to resolve them as different things and get a spectra of each using adaptive optics. And the spectra on the right, Pluto's the top one and Charon's the bottom one, and you notice they're different. They do look different. They're kind of excited. So thanks for having me here tonight. Appreciate it.
Well, thank you so much for watching our program again. We would love to see you at one of our future meetings. And if you have any questions or comments about this show, please do feel free to contact us at lookuptonight@ocastronomers.org. We would love to hear from you. Good night.